So I'm here to talk to you a bit about lessons we've learned or our customers have learned from deploying things out at the industrial edge. My background is I'm the CTO and co-founder at ZEDEDA. I also have these other hats that I occasionally wear, and I will wear them a little bit today. So Linux Foundation Edge is an open source foundation under Linux Foundation. And Margo is also this open source effort that is standardizing things, which I'll talk about a bit later in the presentation. So quickly, what is ZEDEDA? Well, ZEDEDA, our goal is to make edge computing effortless, open, and intrinsically secure. And I won't go into the details about what edge computing is, but it's what you guys do, right? Sort of like industrial edge, things that are very distributed, could be unattended with no staff around for hours. It could be with non-IT staff around. It all varies, but it's actually very distributed in general. And we actually are in many different verticals. This will make a bit more sense once I talk about what we do, right? But oil and gas services, as well as other things like railroads and shipping that I'll talk about today. But agriculture, manufacturing, automotive, retail, it's the gamut. What do we actually do? Well, we're taking what people have been gotten used to from a software development perspective in the cloud and extending that out to the distributed edge. So sort of, if you've heard of cloud native development, people building containers, CI/CD pipelines, this is how people run things in the cloud. And in the cloud, sure, you press the button, somebody wrote some new software yesterday, it's tested overnight, it's deployed today. Well, in your domain, it's not going to be deployed today. It's going to go through some additional months of validation, whatever, before it actually gets deployed. But it still makes sense having that initial sort of developer thing to be able to quickly develop, evolve things, do the initial testing, even if there's additional gates until it actually runs out in the field, right? And this will become even more prevalent as people are deploying AI models as opposed to just software. So this is a SaaS solution. So this picture actually shows that thing with 3 colors on top, right, is actually running on one edge device, or more like it, a couple of hundred or thousands out in the field. It connects to anything over whatever network technology is there. We have this open OS in orange, which I'll talk a bit more on the next slide. But then you run different applications, different workloads if you're coming from the cloud, which could be VMs, virtual machines. You have a Windows app that you want to take and do what in the data center was called lift and shift. You take your Windows app and you run it on top of a virtual machine, the way people run things in AWS or Azure. Or you have containers, Kubernetes clusters, something else. We are not involved in the actual data. So if you're running OPC UA, whatever, you will continue running that, shipping that off to your data center, shipping other data to your historian, shipping it to various clouds. We're not involved in that at all. We are strictly about the orchestration pieces, whether it's the AI models, whether it's about your virtual machines, your containers, and making sure that you can actually operate that at scale. And one of the key things we do is build this stuff using zero trust. So there are new security challenges out at the edge that I'm sure you guys are familiar with. I mean, we've already had customers that had their hardware stolen, right? And they ask, what happens to our data? Well, your data is secure, right? Because it's actually tied to everything else. I think the marketplace is actually on the next slide as well. But that's sort of what we do. And then we have an orchestration system or a fleet manager or whatever you would wish to call it that provides various northbound APIs if you want to do it through UI, if you want to do it through CLI, if you want to do it through something called Terraform, which is used in the cloud for doing large-scale sort of deployment and orchestration. So all of those pieces are there. And the whole, what isn't shown in the picture is the autonomy of this. So yes, if you want to deploy a new application, you need to be connected to the orchestrator. But if it's running, well, it doesn't actually need any connectivity to the cloud, right? because it's actually the applications, they keep on running independently and securely, even though there's no external internet connection out of your site. So the three pieces that we actually do, one is this ZEDEDA Cloud, which is shown using a UI because that's what you can show, but it has lots of APIs for integrating with it. And then we have, which is a SaaS offering that is deployed on different clouds around the world, different private and public clouds. And then we have an open source project in the Linux Foundation called Project Eve. Stands for the Edge Virtualization Engine, but it's basically the runtime that makes this stuff secure out at the edge. And then we have a marketplace. That marketplace includes sort of infrastructure applications, as well as hardware partners and sort of other verticals that come in here. And you see some of the hardware partners at the bottom of the slide. So a lot of this is giving the people that want to deploy it being able to take whatever application in whatever form factor they have and go and deploy it on some hardware that actually makes sense, and providing the glue in between those things to make the thing be scalable, secure, and robust out in the field. And since I have all of you guys here, and I know that people talked about security earlier in the week here, I had to get on my cybersecurity soapbox. So I happen to care a bit about security in this cyber physical system. So people have talked about this week about secure by design, secure by default, right? But come on, let's get real. I mean, we have all this legacy software. It's not going to get secure just because we wish it to be secure. Whether it's software, whether it's firmware. So what do people actually do? Well, today they build things by having the layered architectures, networks, proxies, whatever, isolating things from a network perspective. But they're by and large not actually doing anything in the software stack. So the fulcrum of Archimede, I can't speak English sometimes, is a key value here. And one of them is clearly this sort of network security functions when you do isolation. But the one that most people don't think about is that if you can actually isolate things on the actual box using software, and in particular isolating the device infrastructure software from the actual applications, now you can actually get additional more leverage. You can still have that application built using Windows XP, right? And you can still securely run that on a platform that provides this level of isolation, where there's other pieces that can actually extract the data out of it, running on the same platform, getting it out somewhere else. So this is actually adds a level of flexibility in terms of how you transform things gradually. So you can actually get to a more secure posture over time. You can have your legacy, you can start introducing new pieces that are implemented with secure by design principles, but you don't have to go rewrite your whole stack, your whole software, all of your software components at once. So that's sort of my soapbox for the day, and then we get into the actual use cases. The rail use case. So 20,000 or more nodes distributed all over the place. So one of our customers, right, they have 8,000 locomotives, 535 million tons, and 28 states, and all of these detectors distributed out. Today, these detectors are there to detect heat from your brakes that are locked up or wheels that are locked up, and 32,000 miles of track and highly regulated. So what are their challenges? Well, they need to get more devices out there, more sensors out there because of new safety regulations. And what are the challenges? Well, the scale is number one. Number two is security. So even though these are in some sort of cabinets, boxes along the track, right, where they're gonna run these computers, but by and large, this is actually not that secure. I'm sure you can get in with a crowbar, right? Connectivity is actually quite diverse because it is along the whole track. It's similar to what you would see along a pipeline, oil and gas, right? It's very, very spread out. And the environmental range for this. So you have to definitely need hardware, et cetera, that can deal with a wide range of things. And then, you don't have any local IT staff, definitely, and you don't actually have any staff out along the track either. I mean, maybe at the rail yards, etc. So, and there's a need to grow the number of applications. So not only are they going to put out more boxes, but they want to be able to leverage that data that they're getting, not only from heat sensors, but from cameras, etc., to implement different functionality. So how did we actually go about solving this? Well, we already have tens of thousands of devices running with our stack distributed throughout the world, orchestrated centrally. So 12 plus Fortune 500 companies doing this stuff. So we built up a fair bit of credibility. So some of our known customers is Emerson and Rockwell in this context. So, but there's other ones as well across other verticals. And one of the key values was actually the zero trust approach we take to this. So we leverage hardware like trusted platform modules, which either come in the form of firmware or TPM chips, available on both sort of Intel, AMD, as well as ARM-based hardware. And a set of security technologies that are there to enable not just, to basically enable to check the integrity of the software. So what is actually key here is that no one can sneak in, whether it's in the supply chain when the box is delivered or while it's out in the field, and change the BIOS configuration or put their own little BIOS or change the OS that it boots, have it boot off of a USB stick, whatever, right? And remotely, if you didn't do this, you wouldn't be able to tell because the application is still running. But they're now running it on top of some OS that is actually siphoning off the data and potentially manipulating the data as well. So the ability to ensure that the underlying platform has, guards its own integrity so that you as an application developer, deployer, operator, you don't have to worry about that part. You have to ensure that your application is reasonably secure, but at least you're running on something that is known, right? Your house is built on a sound foundation, not on sand. There's other pieces that play into security, which is, and from the robustness perspective, that if you want to be able to update these things, it means that occasionally you have to patch the operating system itself, the underlying EVOS that is actually running these workloads. Well, how could you do that robustly when you might not have reliable power? You might not have UPSs sitting out in these closets. So the power could actually go out while the update is running. How do you make sure that that doesn't turn it into a warm brick? Right? So there's techniques that people have used in different domains where you have separate partitions, separate places you boot from, and you atomically switch over from one to the other. We've taken that as well as verifying that, well, the new thing you're running is actually working before you actually commit to it. So this way you could actually do this stuff and it doesn't matter whether the power goes out in the middle, it will retry later. So that's a key thing. We have built natively into EVOS, and this is all open source. So you can go to LF Edge and read this stuff and look at the details. We built in connectivity to handle not only what you see in a data center with sort of Ethernet and one Ethernet. No, you can have two Ethernets. You can have one that is on the shop floor and one that talks sort of up the stack, right? But also you can have cellular connectivity, you can have Wi-Fi, you can have different radios, and some level of control about falling back to more expensive networks, etc. So that's sort of what comes out of EVOS itself. Then in addition, with partners, you can now go deploy, have your own sort of firewall / VPN, SD-WAN, right? To be able to have more control. Well, you deploy that typically as a virtual machine image on top of the platform. If they actually offer this in the form of containers, you can deploy them as that as well. And that combines with the actual applications that you might want to run, whether that's an OPC UA, MQTT relay, some AI, inference engine, whatever. They all run on the same hardware and software platform. So if you're concerned about the footprint to install this somewhere, well, you need to make sure you have a piece of hardware that has enough capacity for what you need, but it could be that size or it could be that size, right? It depends what workloads you actually need to run. So that connectivity is key. And then the fact that it's so resilient against outages, the operating system itself is immutable, meaning that you don't actually go and incrementally update it, patch it. You're running, and if people are familiar with networking gear, they typically work this way. You run a particular image, you go and update your router and switch to run a new image, right? But it's not like you're changing it incrementally, like my laptop running, talking to Ubuntu, downloading things, or talking to Windows Update, incrementally changing things. No, it's immutable. It either runs A or it runs B, or V1, V2, V3. And that means that you can actually deal with this in combination with supporting ruggedized hardware. And the key thing is actually, once you have this deployed, you can actually tell, I pushed out this update to my application. What is actually running out in the field? Did it actually get updated on all of them? Because all of this stuff is distributed. So at any point in time, something is actually disconnected because of the network, or it's powered off or whatever. But so you actually need to be able to go in and see, okay, a day later, a week later, did the update actually get applied? Is this new application actually deployed? So being able to do that at a fleet level with 10,000, 100,000, right? This is what we enable, and that is actually key for this particular use case. So the actual solution looks like this, where you have these little sheds, bungalows, I guess they're called, and that is actually running a server. I think in this case, it was actually an NVIDIA Jetson with GPUs, and sort of a number of them, depending upon how many cameras they had connected to this stuff, to actually do the video analytics to detect things that are wrong, right? And that is then connected, depending upon the location where it's at, over different types of networks. They have a sort of combined network operations center where they can see their applications. They can see what's going on from the sort of rail safety perspective, as well as connecting to the orchestration system in terms of deploying new versions and observing that as well. But this is just a starting point. So the goal here was not just to solve the existing problem of getting more sort of video cameras out there, but also looking at what are the other things that they need to do, which they can do with the same hardware platform deployed out, and in many cases with the same cameras as well, right? The wheel defects, but also if they put these things near rail crossings, they can point cameras at the crossings to see, hey, did the car get stuck in between the crossing gates? They want to expand it to be able to keep track of the sort of container payload tracking, and things like the trespassing, and keeping track of what is going on around the rail, right? So at some level, this is getting some flexible compute hardware and software infrastructure out there, so that now you can actually deploy different applications operating on the same data. If you need more data, sure, you might need to go out, send someone out to plug in more cameras or whatever additional sensors you need. But that's all you need to do. You don't need to send someone out just because there's a software issue, right? A new version of software, the box doesn't hang, right? It actually has enough robustness that it resets and restarts automatically, so that it should never be. We've had cases in the past where you had to send someone out in a cherry picker up there because there's a thing with the camera, just to press the reset button so the box will reboot, right? We don't want that, right? We don't do that. It does that by itself. So that's the key thing for the rail use case. A different use case, the maritime shipping. So $21 billion, what is $21 billion? Well, one of our customers, they have 600 vessels. These things spend most of their time at sea. It's interesting if you want to do hardware maintenance, because they don't spend many days in the port. So if you need to replace the hardware, it's either a helicopter, or you have like 24 hours while it's at port or something. So they have lots of different ports spread around the world, and they have a new acronym. What is it called? It's a 10-foot equivalence unit. So the equivalence unit of a container, because they're 10, 20, 40 feet containers, right? So that's the number of things that they ship, and about 1 out of 15 of those is refrigerated. And here's where the sort of key value of this is dealing with that, because the cargo that's refrigerated, it's actually key that they track that stuff from, is the refrigeration actually working or not? So if they don't actually have connectivity, they can't keep track of these particularly refrigerated containers, and they now actually lose lots of money, right? So that's the thing that they want to avoid. So what are the challenges? Well, integrity from the perspective of these containers. Integrity of the overall system. But then these things are sitting inside the containers, right? Part of this software is inside the containers themselves. Those things actually move around from different, they might be on the trucks later, etc. So, during the life cycle of these containers moving around, different people are going to have physical access to those things. They might be on leased vessels, etc. And the connectivity is actually varying and evolving. So there's some places out there where they have built a 2G cellular network on the actual ship to connect all of this stuff together. They're moving that to 4G. Right? The uplink has been using geostationary satellites, which is actually expensive. Right? They're moving this stuff to Starlink. Leveraging LEO and lower cost. So they need a lot of flexibility in terms of this connectivity. That's the key thing. And then, how do they actually then get from that onto the shore devices? And again, remote orchestration, right, is actually key. That you can actually control what you're doing, what applications are deployed. You can see what versions. But doing that both of, I joke that this is containers in containers, right? It's actually Docker containers inside shipping containers, but it's also virtualized appliances. So one of the ways they do the networking things is they have this thing that's called virtual network functions. Basically, you take a firewall and you take that in a form factor of a virtual machine and you run that. So that's the key thing. I think that there's some cases here as well that which is something that we have built, is the ability to do some operations locally. So even if you lose your uplink, the local staff, not IT staff, they might see if my application isn't working anymore. Can I just restart it? Right? Can I try again? And providing those sort of local operations separate from the orchestration that's more global. So what did we do to solve this? We're leveraging these IoT sensors that are deployed out there, right? And it's the same security building blocks that we're using in general to ensure that these devices cannot be tampered with. We have the local connectivity, and this is actually together with partners to have the packet core to be able to run the cellular network on the ship. And then, communicating with firewall, with uplinks, an SD-WAN partner that enables them to determine whether they're going to use the geostationary satellites or Starlink. And then, that you actually have from an operations perspective, you can actually do some things locally, right? The operations that are needed to run this thing. So that's the key thing from running that use case. So this is actually some set of small compute nodes actually deployed on the ship in the containers, and then as well connecting to third parties, other partners to actually get the additional services that they need. So what is actually next for this particular customer? It's actually consolidating the network side of things, and then bringing in other applications for the ship, not just for the particular thing about the refrigerated containers, so that they could actually leverage that to help with operating the vessel as a whole. And then, expanding this stuff out to chartered vessels and other partners that are part of the overall sort of transportation chain for these containers. So that was the main thing for those use cases. I'm gonna now put on a slightly different hat. And I don't know how many people here have heard about an open source / standardization initiative called Margo, if you can raise your hand. It's like, okay, a handful of them that have heard of this stuff. So this is actually something that we're active in from ZEDEDA, but it is actually something that is might be interesting to other people in the room here. So Margo set out to create some more interoperability at the edge for industrial automation, and getting this as an open standard as well as open source components, so that you can actually develop applications and then deploy it, whether you're using in Rockwell Automation, whether you're using Emerson, whether you're using Siemens, whether you're using these different vendors that actually have their equipment in the factories. So from an application perspective, if you're deploying something that is targeting a particular industry, you can do that once. That's the sort of promise here. And then deal with the workforce scarcity in the factory, and you don't necessarily have trained workforce out at the very sites by doing remote orchestration at scale. So you can actually drive this stuff centrally. So it very much aligns with what we already do. Getting this set of competing companies to actually work together to define a standard. For these pieces, they will of course provide additional value around it, right? But getting that interoperability by having collaboration in the context of open source. So the steering members is actually a set of companies here that might be familiar from a industrial automation perspective, but there's also others like, Microsoft, Red Hat, ourselves, right? That are actually more coming from the IT and software side of things, that are all participating in making this stuff move forward. There are other parties that have actually joined later. So there's some other sort of smaller companies, or not so small companies, but they're also involved in this stuff to try to move the stuff together in a collaborative fashion. So that was what I was planning on covering. Oh, that's right, my learn more. By the way, that thing at the bottom right is the edge monster. But if you want to learn more about ZEDEDA, you can actually go and get, try it out. You can actually go watch videos, whatever, at the Edge Academy. You can even get certification on this thing if you want to learn more about what do we think edge management and orchestration is. There's an LF Edge open source project. There's Margo with its website. And then there's Edge Monsters. So what is Edge Monsters? Well, it's, I guess, my fourth hat today. So there's a set of architects in various verticals that have experience with already deploying and operating things at the edge. One of them that is actually quite known on the internet is Brian Chambers at Chick-fil-A, that he basically deployed these little Intel NUCs, 3 of them as a cluster in every restaurant. And they built this stuff like 6-7 years ago, so it's been out there for a while. But it's an example of actually taking, sure, it's not a factory, it's not a ship, but it's still sort of a very unknown environment because you don't have physical control of whatever closet that's sitting at right? And the hardware actually breaks, you need to be able to replace it, etc. Right? So it is sort of leveraging software to make this stuff be robust. So this group has that type of experience, and the goal here is to share with the rest of the community, the other sort of architects that are thinking in this domain, what are the lessons learned? So there's actually blogs over there. A recent one is about AI, right? In terms of how to think about AI at the edge. What are the things that people might not have thought about, right? Because they're caught up in all of the buzz, but what are some of the things worthwhile to think about? So that's, if you're trying to learn more about edge, right? I would actually go there and read the blogs. I think there's a blog coming out once a month. And that was it. Any questions, comments? So either I was like way too marketing-like, or I was way too technical, so which one is it? Okay. I think there's a mic coming to it. Oops.
So you have your own ZEDEDA cloud, right? Which is you are using to manage all the edges deployed across.
Yes.
Uh, how does it seems on the cloud cost point of view for doing all this stuff? Or is the data coming? Is it cost prohibitive with 20,000 nodes, or what
No,
kind of data?
and the way ZEDEDA offers this as a, so I'm going to wear two different hats here. The way ZEDEDA offers this as a business is software as a service. So basically, you're paying per year per node, right? That is not very expensive relative to the cost of hardware, et cetera, and the value that the stuff normally delivers, right? The data that is your data, whether it's analytics off of your, production side for oil and gas, that data doesn't even go to us, right? But we're enabling you to deploy applications that typically take that data and distill things, run analytics on it at the edge, right? Maybe more, training it to do actually AI in the future, et cetera. Right? But that data is all yours, and it goes to wherever you want it. You want to keep it at the edge and you only get the results. You want to ship it off to your data center, whatever, your virtual private cloud, et cetera. You can do that.
Okay, but if you run all the AI or workloads on the edge, does it require huge computing resources? You need high availability and these kind of things.
So it depends on. So I think AI is evolving very rapidly, right?
Yeah.
So I think that, and it's very hard even for me to figure out what's going on, because most of the thing you hear is about people building the largest language model on the planet using millions of dollars to train it, right? And billions of dollars of GPUs, right? But there's all of this other stuff that's going on, machine learning, right? This is not new. People have been doing this stuff for I don't know, a decade, right? And what is actually happening is that the hardware cost is actually dropping if you need GPUs, right? You can get more efficient, lower cost ones than you used to before. Like NVIDIA, they build these very large ones for the big guys, but they also have the Jetson family, which is these very small, ones for a couple of $100s. So that is changing. But the other thing that's changing, which is more recent, is people are figuring out more efficient ways of building software. So, and I think the upshot of that is that people think that in many of these edge use cases, you can even do sort of slow frame rate video without a GPU, because people are making these models be better, right? In terms of the software refinement, and this is happening extremely fast. So if you think it doesn't work today, right? Well, you need to come back 6 months later and look again, because it has changed, whether that's the hardware having come out with newer, more efficient ones, or just the software stack, the inference engines, right, having evolved. So it is sort of like people are starting to do this for some of the existing sort of analytics cases, right? And I think people are also doing it to do these sort of small language models. How do you make sure that your non-IT staff on site can learn based on your company's sort of experience by putting that in front of them and running that actually on the computer at the edge, right? So that they can actually ask questions and get access to all of the documentation and experience that is embodied in that small language model. So this is actually something that's actually quite recent, but that's happening as well.
Okay. The last question then. You said you have the immutable images
Yes.
at the OS level. So does it, when you kind of update those images, create some downtimes and problems with that? Because
Yes. Yeah, you need to reboot the system when you do that, meaning that the actual applications that are running will have downtime when you do that, right? Yeah. So typically you have maintenance windows for doing that, right? So, but that's something that you can actually orchestrate centrally, right? And then sort of make sure that you get the appropriate approvals, because it might be the person that's responsible for running that particular production line, whatever, that needs to sign off, right? When are we doing this stuff? So.
Okay, thank you.
Yeah, thanks.
Hi, Mark Lee, Dow Inc. Um, got a question, two questions. So first one would be, I missed part of the workshop. I was coming in late, but I did talk with people at the booth. For managed, so one of the challenges that we have is we have a lot of edge computes, or we will get more in the future. With a lot of sensors and IoT. One of those issues is having an identity for all of your edge compute devices and then managing those identities across for security. So being aware of said devices, I'm guessing ZEDEDA does something for that managed identity kind of edge compute awareness then?
Yes. So we're leveraging existing standards for this. One of them is the TPM chips. The other one
Okay.
is X509 certificates. So
Okay.
each device, when you onboard it, when you install EVOS on it, it actually generates a certificate in the TPM.
Okay.
And what this actually means is that the private key that is really the carrier of the identity, it never leaves that TPM chip. It's impossible to extract it, right? So you can actually, sort of forge these things or duplicate them. And then the onboarding process means that you now securely exchange that stuff with the ZEDEDA cloud, so it actually knows that, by the way, I have one more device that I'm going to manage.
Okay.
But the foundation is built off of very strong security here.
Okay. And then the second one would be for remote attestation. So, for example, say someone maliciously is trying to either replace a piece of equipment or add a USB key to an edge device. What are the different interactions that you can control for that? I'm guessing that would be a local like attestation at the edge and not like a cloud-based trigger.
So this is actually a place where we had to innovate, but it's using the organization that has standardized the TPM chip, right, called the Trusted Computing Group.
Yes.
They've specified how remote attestation works in general, and they have all of these other mechanisms that is called sealing a key, a cryptographic key in the TPM under the measurements of measured boot.
Okay.
And using these things, what we have built is actually documented on the LF-Edge web pages in a lot of detail. It's basically saying, as long as these measurements, so the measurements include like, what is actually the BIOS settings, the BIOS firmware software itself, right? Various other hardware components, like do you plug in another Ethernet card or another storage device, the operating system you boot, the immutable root file system image, right? All of these things are part of the measurements. And if those measurements are the same as last time, then the software running can autonomously get the key to decrypt the actual file systems, the volumes for the applications.
Okay.
And if it's not the same, then it has to go either get pre-approval or post-approval by talking to someone. So you can actually do pre-approval where you say, okay, I know I'm going to roll out a new version of the BIOS. So either this cryptographic hash or that one are okay. Right?
Okay.
Or you do it after the fact that, okay, I know that I took this thing in for maintenance, and when it comes up again, I will just post-approve that here are the new measurements, those are okay. In those cases, in the post-approval case, you have to be connected to do that post-approval. And until you do get connected, the applications will not actually start because they want to access. But in the normal case that the power went out, it reboots, whatever, right? Nothing
It's
changed.
the same, yeah.
Everything just runs autonomously.
So the attestation happens on the edge compute device, and then it locks it down, and then the post-approval would come from the cloud, I'm guessing.
Yeah.
That's correct. But the actual lock on that on the device, the compute, is local to that, or remote in this case, in the PowerPoint slide. Is that correct?
Yeah,
Okay.
It's autonomous on the device itself.
Okay, that's good to know. Thank you.
And I think that this is sort of one of those cases that you have the same thing implicitly on your laptop or on your phone, right? If you're running with us. But then the assumption is that approval is you actually saying this is okay, right? If you have updated something, if you're running Android in developer mode, right, you get to approve that, oh, this is okay by interacting with the screen. Well, you can't do that because there's no one sitting in front of any screen. It all has to be done slightly different. Any more questions? Thank you very much. Have a good afternoon.